going to talk about Aeron Clustered Sequencer. I'll do a little brief introduction about what are sequencers. I think they're fairly well known, but I'll do a bit of an introduction about sequences in general, and then the Aeron Clustered Sequencer and why we think it is special. Many of the reasons that Aeron is special, I guess. And then feedback cycles. So there's a call to action, I guess, which is that we are building now an Aeron Clustered Sequencer, and we love to get feedback as we go. So there's an ask. In fact, this is an announcement to this audience. We hadn't gone public on that until the last meetup, but we're building a sequencer. We think it's pretty cool. If it might be interesting to you, if you'd like to know more about it, then talk to us. We're building a set of interested organizations that might not need it now, but might need it in the future, and that can give us fast feedback, so failing early, getting feedback early, making sure it suits the market. So there's an ask around feedback cycles as well. So what's a sequencer? In the very simplest form, a sequencer is a global index, an ordered list of events that are happening in a system. It's not a new idea. It's been around. I guess the island architecture is fairly well known. It's been around for a few decades. Essentially, the architecture is that everything comes into a sequencer. It gets a sequence number, an index. It gets logged. It gets decorated, maybe with a topic or a category, and then it gets shared out to systems and services that can do stuff with it. Deceptively simple, I'd probably say. Often these things are built using primary backup, and this is a picture of how a sequencer architecture might look. So we've got a sequencer in the middle with a backup offering some resilience underneath it. We have the way a sequencer might engage with the outside world is through a set of gateways. That's the only way of being able to get things in and out, so external services going through sequencer gateways. And then services that do work, matching, risk, order management, whatever, at the back end being connected to that sequencer too. Messages come in and messages go out of the sequencer. They're all logged, and so that provides quite some benefits. So it gives us a definitive order, which really, really helps when it comes to debug or forensics or what actually happened. So you only have to look at the sequencer. You don't have to start looking at timestamps and correlation between various systems to work out what actually executed, what happened. What else? Okay, so there's a consequence. We add another network hop rather than just doing things in a in an Aeron cluster. So we do have some trade-offs. There's another network hop to get to the sequencer. But those services and gateways can be independent. So for organizations that are more sophisticated, more complex, then you could have different teams working on different services that might be using different languages, that might be releasing at different times. And so you can add independence to those teams so they can work in the ways they want to. And you can minimize risk because when you're making changes to systems, you don't have to change the whole world. You can just change single components. So that means operating at scale in large and complex organizations is one of the factors or features that sequencer architectures can offer. Certainty, sometimes performance, I think is probably true. But another consequence is that these things are deceptively simple. I mean, how hard can it be to make a global ordering system? Well, it turns out it can be quite hard, and we know through the work we do in the rest of Adaptive, working in our consulting business, that many organizations have tried, and some organizations have succeeded too. In fact, at the New York event, Talos, Ethan was telling us about how they built a sequencer with this kind of style architecture, not a cluster, going real well. But one of the other features is that it ties up some really strong developers, not just for development, but for ongoing maintenance. It's quite a sophisticated, powerful, complex thing, and getting folks out of development, out of support, into building your competitive advantage is really hard. So do you really want to be tying up your best developers to work on some fairly undifferentiated technology? So that's why we're kind of excited about it as Adaptive, as well as being excited as part of Aeron. So that sequencers in general, our clustered sequencer has a few components, very similar to the picture that I put up at the start. It's built on Aeron. It has at its heart a sequencer, but it's a clustered sequencer, not a primary, secondary sequencer. So that gives us some good Aeron benefits out of the gate. Fault tolerance, it's the central log, can support all sorts of active, passive setups. It does the deduplication and does filtering and of categories. Other solutions like this might call them topics, we call them categories. We've then got our service container, so we can run clustered, resilient, 24/7 services that connect to the sequencer at one end. We have gateways. They say for fix or market data. When we build our sequencer, it's business agnostic. So you'd build the fix capability, the market data capability, talking through our gateway clients. And then our protocol that now allows us to be able to have actors join, systems recover, giving us observability and all of that cool stuff. So those are the kind of key components. And then this page talks about, well, why do we think it's special? This stuff on the left, the foundational stuff, is the stuff that is the reason that many of you are sitting here today for why we think Aeron is different and cool in the market. Determinism, predictable latencies, getting rid of long tails or understandable long tails, deploy it anywhere, in the cloud, in the data center, across both, be able to handle loss, particularly important for the cloud. And again, options in terms of multicast, multi-destination cast, unicast, all of that stuff, with some foundational authentication, authorization, and all of that stuff. Some more so what's around fault tolerance. So, really true 5 nines, less than 5 minutes a year downtime, rolling upgrades, all of those things are enabled with our sequencer. So really supporting high availability with all of the kind of recoverability things that hopefully you know and love or are learning and love about Aeron and Aeron open source. High throughput. So we don't claim to be ultra low latency, but being able to handle large workloads predictably, high throughput with predictable latency, then another thing that we think gives us an advantage on the sequencer side. And then on the premium side of Aeron, so this is where you get support and access to these premium components, then there's a pile of additional things that we think help to make the sequencer pretty exciting. So kernel bypass, writing stuff straight to network stack, fast encryption, ATS, and then cluster standby. I think cluster standby is not well understood. So it's not just about having a cluster that's on standby. It is also for being able to spread your workloads, being able to do archiving to slow systems without slowing down your main clusters, being able to give you resilience across data centers. It's pretty cool. I think we haven't explained enough about it, and that might well be the subject of a future talk. So that's what Aeron Clustered Sequencer is all about, some of the components and some of the reasons we think is pretty awesome. We know many of you are building or have built sequencers, either with Aeron or not. In fact, Adaptive sometimes does that for customers too. We're thinking that means that we have the hard-to-find, expensive developers that build this stuff, support this stuff, in our business as our competitive advantage, if you like, means that you don't have to. So your developers can focus on your competitive advantage, making money and changing the world, all that good stuff. So that is our sequencer. If you want to talk tech about it, then I will rapidly run out of runway, and probably those kind of conversations are good for the networking session afterwards. But otherwise, if there are any quick questions, then do shout out. Will the sequencer be a free feature? At the moment, it is a paid-for feature, and at the same time, there's no point in having software that isn't used, right? So at the moment, foundational users of the sequencer have value to us, so come talk to us, I'd say. RTO is, in fact, I should do a quick plug for RTO. So RTO, for those folks that don't know it too well, RTO is our fix engine. We use it as a key part of one of our other products, Hydra. So Aeron is all about high-performance messaging, and Hydra is about technology acceleration. You know, the building blocks of replicated state machine systems that take a lot of the rough edges off Aeron and enable us as Adaptive to build systems fast for our customers, and actually for those customers that choose not to have so much adaptive consulting, enable them to build their systems fast too. And so we use RTO, the fix engine, as a big part of our Hydra accelerator. So having gateways to the outside world, whether they be for web, market data, or fix, is really, really important. And recently, we have started introducing a new RTO support service. So it's a reasonably limited RTO support service. We try to support customers that use RTO in their business the same way as we use it in Hydra, in our business. And that enables us then to invest more in RTO, get more people on the pitch, and to build it out. So our view for where RTO fits in our portfolio as a whole is to be able to provide the kind of fault-tolerant, high-throughput, resilient fix that the market needs. So our support service for RTO helps us to invest in making RTO better. And then some of our other products, like Hydra, the accelerator tools that we've got, make extensive use of RTO, because getting stuff into the outside world, these fixed gateways on the previous page, well, why wouldn't you use RTO or parts of it to make it all work?
But is it going to use cluster?
To be determined, right? So RTO has its own resilience mechanisms built, and Fix has its own resilience mechanisms built in. And so, as the market moves to, as there's more demand for 24/7, more demand for rolling upgrades and such like, then we will be bringing our whole stack with us so that we can meet that end-to-end demand. Whether we keep an RTO label on it or something else, we know that that's stuff that the Adaptive stack and Aeron needs to be able to deal with. I'm going to ask a friend, and I might ask Martin to talk about latency in the sequencer. So one of the cool things that's happening at the moment as we build the sequencer, one of my jobs is to protect Martin from the rest of the organization so Martin can build it. So do you want to comment on latency and the sequencer? Where's your head at?
Okay, so think about what we're going to share publicly. I've seen a lot of cluster implementations. I've seen a lot of sequencer style implementations. One of the things that we want to achieve is achieve the lowest possible latency without giving up fault tolerance. Now, a lot of people will give up fault tolerance and often not tell the truth about it. And that's one of the things I just don't believe in. So we'll keep it really open. Now, when we build it, we've been having discussions about what modes it can run in. So one of the modes I think we can offer is a particular latency mode that would be very low latency. Sort of similar to cluster, and some of what we're seeing in cluster in certain environments is like very impressive compared to anything else out there without giving up fault tolerance. But I guess grab me and we can talk about it maybe a little bit later, but I don't think we're ready to publicly talk a lot about how some of the modes can be offered yet, because we got to decide what we want, and we don't want to have too many modes to it, because that adds complexity in its own right.